I'm going to wait one more minute. Thank you, everyone, for participating in our second session on maritime extremes. And I think from the first session, we had a really, really nice session, and we had some great discussions that focused on information, the importance of security, and actually the importance of how we use information, how we trust information. And I would like that we use this session to continue this on, this topic. And I am very proud to moderate the session. I'm Penelope Wagner. I'm the head of the Sea Ice Operational Service at the Norwegian Meteorological Institute. Our office is based here in Tromsø. So these topics are very near and dear to our heart right now. So without further ado, I would like to introduce our first keynote speaker. I would like to introduce Malte Müller. He's our senior scientist at our division in Oslo, in the weather forecasting division, and he's also associate adjunct professor at the University of Oslo. And he has a long expertise in weather and sea ice forecasting. So.
Yes, thank you very much, Penny. I summed up studies from the last several years. So it was mainly the FOCUS project from the Research Council, the PRISMAS and Sudaku program from the Fram Center, and also the PCAPS WMO program, which is ongoing at the moment. Okay, so the sea ice in the so we expect that in the next 20 to 30 years, the summer sea ice, the Central Arctic will be ice free, and so it will open up new shipping routes, new opportunities for the shipping sector. And so this is an illustration here. So the most I think it will enable the Northern Sea route more, so there's a lot of shipping already ongoing, but especially the transpolar route will be open in the next decades. So that means, or I would like to emphasize that this is also a summer sea ice prediction or projection. So there will be still sea ice in the winter in the coming decades. So that's why sea ice forecasting stays important also when the summer sea ice is gone or more or less gone. So what we were interested in these projects I mentioned before is that how sea ice changed in the, how the shipping changed actually in the past years, and also how the sea ice changed in relation to environmental conditions. So for example, how many ships are operating actually in sea ice, how many ships are actually operating in weather conditions which are hazardous. So we wanted to understand this from a point of view of developers of weather and sea ice forecasting systems. So in which regions, in which areas, and in which time of the year ships are most exposed to hazardous conditions. So we did an analysis of the AIS database, which starts more or less in 2013. And so we covered 10 years. You see this here on the graph. So this is the amount of shipping days per month there are operations in the Arctic. And you see that over the past 10 years, shipping increased by about 10% each year. And So we divided it up into different sectors. So these are the different colors here. And when we exclude fishing, it's about 7%. When we include the fishing sector, it's about 12% increase per year. So this was just one part of the study. So we were interested in, as I said before, for example, when ships are exposed to hazardous conditions. And we had in our study, we took several hazardous thresholds, so to say. But for sea ice, we followed what the Polar Code describes as a hazardous sea ice condition, and this is generally described by closed sea ice. So we analyzed ships which were in closed sea ice conditions according to the to satellite products we have. And what we found is that like 10 years ago in the 2013, 2014, it was rather a low amount of shipping days. But over the 10 years, it increased quite a bit. So you see this here on the timeline. The green curve is the monthly values. The peaks are in the winter, obviously, when there's most of the sea ice, especially because most of the shipping happens in the Northern Sea route. Oh, you hardly can see this. So this here is a spatial map of where the shipping happens in the winter time or in sea ice. You can see here in the central Arctic, it's mostly from research vessels, but then all the other shipping in sea ice. So this is for 2021. It happened along the Northern Sea route. And these are different sectors which are involved here. So there's a lot of ongoing for the oil and gas operations from the Russian sector, which has to be transported in and out goods. And then there are some ships which are crossing the whole Northern Sea route. But you can remember that almost everything for now is happening along the Northern Sea route when it comes to operations in sea ice, which are not research focused. So this also shows that the shipping is increasing over the last 10 years, what I also showed on the slide before. But it also means that at the same time, the sea ice was not reducing with the same, so there's a lot of variability in the reduction of the sea ice. So there are other incentives which drive shipping. Of course, these incentives or the economic factors might be driven by the future projection that there will be no sea ice. But for now, there's no real correlation between reduction of sea ice and increase of shipping. So obviously, when we have more and more shipping in sea ice, there's just a question of time when accidents can happen. And there was an incident in 2021 in the Northern Sea route. So this was in the East Siberian Sea. There was about 12 vessels which got stuck for several days and weeks because of a very fast freeze-up of the East Siberian Sea. I can try to go back. Yeah. So the East Siberian Sea is here. So it's maybe one of the more remote parts along the Northern Sea route. It's very difficult to access. And it froze up very quickly in 2021 in October. So we thought this is an interesting case to look into, especially to understand how decision-making processes work, and if people would use our forecast information we already have on our dissemination services, if they could have prevented this kind of situation. So this is when you look at the climatology. This is this is the East Siberian Sea. This is sea ice concentration, and this is the climatology for October. So it's from the climatology is an average product. It means how, in average, over this decade, the sea ice concentration has been in this particular region. So you see that if you go with a ship along the coast, you will not be exposed to a lot of sea ice. So in that terms, the shipping should be quite possible. And there was also in the same, or the year before the incident happened, the regulations were also lowered, that medium-strengthened sea ice, medium-strengthened vessels were allowed also to pass this part of the Northern Sea route in October if there is no sea ice. But the question is, how do they determine if there is no sea ice? So when we look but in the situation how it was in 2021, you can see here on the right that there was sea ice, and there was a lot of sea ice, and this happened just in a week. So it froze up very quickly. And this is also something which happened before, but of course, which is not included in a climatology. It's just an extreme, or it's an anomaly, which is just averaged out if you use a 10-year product. So in this situation here, these two ships are just examples of 12 others, and they got stuck here in this position here, and they were drifting for 12 days there without any control. So before they could get escorted out by an icebreaker. So we were interested in if our prediction system actually would have been able to forecast this, and it was. And we also know from other projects and from meeting with stakeholders that almost nobody of the decision makers, they really use our sea ice forecasting systems. I mean, I don't want to say that our systems are perfect, so that we forecast every event, but there is a kind of a threshold to use them, obviously, for planning and decision making. So as I said, like this ARC2, I think actually it's the wrong terminology. It should be ICE2 classification, but this is one of the, this was this Golden Souk ship. It would have been not actually allowed according to the regulations in this area if there is sea ice. But again, the question is, how do you actually regulate this if they don't use forecasts and a freeze up happens like this? Because according to climatology, there is no sea ice. So then there are two questions which I would like to go into for the next 10 minutes. So what kind of regulations actually exist to enforce the use of environmental information or forecast information? And then the second part, the more longer part of my second part is about how actually could be sea ice forecast information be more relevant? How can we actually improve our forecasting systems? So for the first part, most of it is regulated by the Polar Code, as you know. It's a part of the international law. And what covers environmental information is the ship classification on one side. So if you don't see it here, it's covers the sea ice classification of each ship. And it has something which is called the polar surface temperature. It says something about the temperature you can maintain equipment and the whole ship, like to what kind of temperatures it is still maneuverable in that sense. So when this is then related to what they call a polar water operational manual. So each ship has to have this manual. So it's an individual process for each ship. And they have to describe how the procedures to avoid hazardous sea ice and temperature conditions. So but it's up to them in a way how they do this. And like there's only one recommendation in the Polar Code, and that describes that they should use climatologies. And that's, of course, something very questionable when you think about temperatures, extremes, or if you think about sea ice conditions, as I tried to describe with this case before. Like a climatology doesn't cover this, and it doesn't protect you from an incident happening like this. So there needs to in the future, there needs to be some updating of the Polar Code in terms of environmental forecast information, in my opinion. So if we switch then now to the forecasting part. So as I said earlier, like for a planning purpose, our forecasting system could be used. But we have to distinguish between two different things here, or even three. So there's, like what I was talking so far is this kind of short-term planning. So it's the planning for the next days and weeks. And there we have forecasting systems for. They have their problems and issues, I will show it later. But they are not meant, or they're not useful for strategic and tactical decision making. As you see on this graph here, they need to have a much higher resolution, going down to 100-meter scales for a forecast for the next day, just to maneuver in ice. I would skip this slide. So when we talk about the short-term planning forecasting systems, as I said, we need kilometer scales. And if you look in the literature, like the errors the models have at the moment, these are kind of the accuracy of the ice edge position is about 10 kilometer. The drift error, so the sea ice drift, there's an error in the forecast of more than 5 kilometer per day. So it's quite relatively large errors if you think about certain regions around Svalbard, for example, or along the coast. So it's something we have to work with. And that's something we started a process with a few years ago that we use more and more machine learning models to first improve the forecasts itself, or actually to do the whole forecasting with a machine learning approach. And here in the corner, almost impossible to see for you, I guess, but it's about sea ice drift. So that was our first attempt in 2021. We published this paper where we used a specific machine learning model to calibrate or to post-process our sea ice drift forecast by using drifters and satellite information. And we could use very significantly the accuracy of our forecast. So this was kind of a hybrid system of physics-based modeling and machine learning models. So we went further with this. This is from a master thesis from Are Quannum in our institute. He was working on a fully machine learning model setup. It's a neural network which predicts sea ice charts. So it was trained on manual ice charts, and it was predicting basically them into the next 3 days into the future. And you can see here, this is a comparison of the ice edge error for a 3-day forecast. And it shows that the blue line here is from the machine learning model. This is from physical models or other model ideas. So the machine learning model is by far the best model system. It has, we don't have to deal with certain problems we have in our current sea ice prediction setups. And a very similar result here. This is from Cyril Palerme, also from our institute. And this is like a verification of our new operational machine learning model system. So it's a system we run now every day and also disseminate via our services. You see the blue line, and the other lines are from the physical model. So it's really in another area when you look at the errors. So as I said, it doesn't have to deal with, for example, data assimilation problems and things like this. It has much simpler tasks to do in that sense. So, and the good thing also about machine learning models is that the training is very, you need huge HPCs for the training part, but if you have a trained model, you can run it on a rather small computer, like a laptop, for example. So you can do the forecast yourself. So it has also a lot of advantages in that direction. So we wanted to go one step further because we know that our forecasting systems cannot be used on the bridge of a ship, so they cannot be really incorporated into tactical decision making. And we have a collaboration ongoing with the Coast Guard for several years now, where they help us to set out drifting buoys and other sensors. And we learn from them how they navigate in the sea ice and try to support them with our services and also try to adapt our services to their needs. So this is like an image just illustrating how it looks like on the bridge. So what the navigators actually use on the Coast Guard icebreaker is that they see outside of the window how the leech structure looks like. They have an ice radar and they have SAR images. And then they try to get these pictures together in a way. So they move the SAR image manually according to what they see outside and on the radar. And because the SAR image is usually like 6 to 24 hours old already. So the ice has moved to the real position where it has been. So as I said, like we have a collaboration ongoing. We are building these kind of little drifters here. So they are they are open source, low cost drifters. We have several projects ongoing where we have we call them distributed observation networks. So we set out like very large amounts of these drifters. Like in one of the campaigns, we had 34 setting out within 1 week. And then we get a very good idea actually how the sea ice is moving. And this is from another campaign here from last summer. So we were going all the way close to the North Pole with a section up. We were setting out 19 drifters in this area. And on the way up, we got this idea that actually we could actually make a real-time implementation on the systems on the bridge of the icebreaker so that they actually get to know the positions and how the ice drift over the last 6 hours, 12 hours, and so on. And the Coast Guard really enjoyed this kind of new product because then they knew how the sea ice actually is moving and they could use this as an additional information, how to basically do this manual forecasting or nowcasting of the SAR image. So this is again this image here. I can flip here. So this brought us further, and we had this idea about like doing what the operators do manually by hand, that we do this actually with a machine learning model so that we use the SAR data of the past and train like a neural network. And we have Alessio Canzlini, who is from the computational physics program at the University of Oslo. He started his master thesis last year and was also with us on the last cruise. So he presented actually his master thesis also on the ship and got feedback from the Coast Guard themselves, how they would like to see this. And in April, he got an Arctic field grant. There we go again on the icebreaker, and then we will test this actually with the ice navigators together. So what he did is, or what he does is he trains that on very small domains. So for a forecast for the Coast Guard, you would not need a very large domain, right? I mean, if you do a local forecast, you don't need really a huge domain. And because we are going down to 10-meter resolution, you also cannot cover it like just from a data perspective or a forecasting perspective. And this is a bit how it will look like. This is kind of a generated AI system here already, where we basically want to propagate the SAR picture just for the next 12 or 24 hours. So in the same line of thinking, we also just got a project from the Research Council, which goes in the same direction, but much more elaborated. It's called Icebox. And there actually we want to really do something new in terms of forecasting. So for now, we actually do all the forecasting on an HPC, and then we send it to the users. And in this project, we want to source this out to an edge layer, where this is either on the ship or on a ground-based station, so that basically the Coast Guard can do their own forecasts. So or like anybody on an icebreaker. So you just download the SAR picture or an optical satellite imagery, and then you need to run an AI or machine learning prediction system into the future. So this is a project we have then for the next 4 years, together with the Nansen Center to work on this. Yes, I'm coming to this is just another image here. Yeah. So this is also a machine learning based prediction. And these are part of our drifters here. So you really, I mean, this is fully AI generated, and you see how nicely actually it follows. And for example, also how nicely it is able to open up leads and so on. So it looks very promising that we can do something in this direction in the future in terms of very high resolution forecasting. So my time is already in minus. So very quick summary. So we analyzed shipping, and we can see that there's a lot of shipping in the sea ice. So this is just to emphasize how important it is to work on the sea ice forecasting on different resolution and scales. And I also try to emphasize how important machine learning will be or is already in the future for sophisticated sea ice prediction systems. Thank you.
Thank you very much for the fantastic presentation. And I think we have time for one question. If anybody has a question? Yep.
You mentioned it briefly, but Sorry, Odd Sveining Harald from the Norwegian Coastal Administration. You mentioned it briefly, but there was a link to e-navigation and the international standard. I guess it's S4111, that's sea ice hazards to get it out on the ships. Is that part of the project, or is that not something that you're looking into?
I'm not sure which slide you are referring to. One of the last slides?
Yes, it said e-navigation on the far right side.
Yeah, this is from the proposal we had. I mean, we didn't thought so far. So the idea was that we bring this, like we have some stakeholders in the project, like a stakeholder advisory group. One of them is NAVDOR, who built these e-navigation systems, and that's basically the link. But in this project,
they know of it. Then it's okay.
Yeah, and we have been
it's
working for them.
It's important to get the information out on the ships, and that's done by S4111. Thank you.
Yeah, thank you.
Thank you very much. And just to say, this was a really great opening to this session. And of course, we know that sea ice is one of the biggest challenges, especially operational challenges for the Arctic. But the session also focuses on the practitioners and how we understand information, all types of information. So it's my pleasure to introduce our next speaker. We're going to move on to the more practitioner perspective right now. I would like to introduce Ben Strong. He is the chair of the Arctic Council Emergency Prevention, Preparedness, and Response Working Group. He also has a very long tenure in the U.S. Coast Guard, and he was managing the AMBER program. And he also has a strong expertise in the Arctic search and rescue and is also a paramedic. So,
thanks, Penny. Thank you. What a start. I disregard the turtleneck. I will disappoint you wildly. I am not a scientist. I'm not a data provider. I'm a little long in the tooth, but I'm really got my start as kind of a simple country firefighter. So I was challenged by Penny to kind of provide an operational view of things. There's been discussion about data service providers, the information that is used by ship's crews, whether they be Coast Guards or Navies or commercial ship crews, how the data is validated, and whether or not you actually have a choice in what data that you use. And again, while I do chair the Emergency Prevention, Preparedness, and Response Working Group, I thought the best way to kind of share an experience from an operational standpoint is to just kind of bring you on a story. So I started in 1993 as a paramedic and a firefighter, which I know you're saying, Ben, this is a maritime domain. What does that have to do with anything? Well, what I do want to share is the data that we used when we were responding to emergencies. And if you look on the left, it started with hand-drawn maps. And that's how we started things in the early 1990s, and then moved on to commercial data with the map that you see on your right, my left. And what was interesting with the commercially provided maps that we used is that at the time, to protect their intellectual property, that map maker would purposely put in what's called a copyright error. So there would be Penny Wagner Street, which didn't really exist at the time, and in the event that somebody copied that map and then used it somewhere else, they'd be able to show that indeed that their data had been hijacked or their intellectual property was misused. But we trusted this information. With the hand-drawn maps, we made that ourselves. When you're on the bridge of a ship, or if you're in a small boat, or you're in an aircraft and you're relying on information from your national service provider, or perhaps you're purchasing data from a commercial service provider, down at our end, there's implicit trust that that is accurate, that that has been validated, and oftentimes it's all that we have. So we work with the tools. We work with the tools that we're given. But I did have the opportunity, fast forward to 2022, and I was on the Coast Guard Cutter Oak. We were steaming in and around Greenland in what was called Exercise Argus, doing some oil spill response and search and rescue exercises. The challenge, however, is we were working in an area with incomplete hydrographic data. So what we had to do is the officer of the deck directed the conning officer, and you can kind of see it there in the lower right-hand side, as they were doing soundings every 10 minutes to make sure that what we were seeing in our soundings matched what was on the chart. I don't think it comes as any surprise that charting in the Arctic can be incomplete, some of it back in the 1800s. And so we were using best practices, using the data that we had available. We had bridge wing observers, folks on the deck with binoculars, and really bridging the gap between analog and digital and using all of the tools that we had at our disposal. The challenge when you're in the field is that there is an absolute flood of data. I don't know how many people I have here in the field who are in the audience who are operators, but I'll tell you as in a little bit higher leadership role with the Arctic Council, my experience has been there's no shortage of salespeople. Oh, I have the next big solution. Oh, I have the next big thing. There is I hate to even mimic the slide that's behind you, but there is an absolute flood of data. And how do you know that it's any good? And if you're in the business of providing data, if you're a Penny or a Multi or anybody out there, maybe perhaps some of you provide services through your meteorological services or through your national services. How do you know that it's good? And then, as an operator, can I choose what I use? Well, I can tell you straight away that no, I cannot choose what I use. Instead, there's somebody who chooses for me. And I absolutely do not have a choice in the data that I use. I can't take a thumb drive and just plug it into the SAT-C terminal, or I can't, if I'm a third officer on a container ship, I can't just decide, oh, we're going to put up a Starlink terminal and use a different service. I'm required to use what is provided to me. So again, back to Penny and the services that she provides. You're getting a lot of good airplay here. So, you know, but I have to have that trust that indeed that data and those services and the ice charts or whatever is being provided is accurate, it's timely, and it's been and there's quality control there with it. So how do you, if you're in this business of providing data, or if you're responsible for a national service, how do you convince me that the data is accurate? And I was so pleased to hear Alessio, am I getting Alessio's name right? So be like Alessio. Go to the field. Come meet the operators. Get on the bridge of the ship, whether it be a commercial ship, whether it be with a commercial company. If you're from Navtor, and I worked with Navtor in the past, go meet the operators, meet the people who are in the field, sail with us, show us your products, and then learn what our needs are. And that's how you best figure out what we need. We can be a scary bunch sometimes, but you will learn so much by involving yourself in exercises. But Ben, it's really hard nobody wants us there. And I'll tell you that while we can be a scary bunch, we do want you there. We want that intersection between academia, between analysts, between scientists, and those of us who are in the field. Don't be discouraged. There are opportunities. Exercises, large-scale exercises, actually have opportunities for observers, and don't let your exercise planners tell you that that's not the truth. What's next? The collaboration with the Norwegian Coast Guard is another absolutely perfect example of how I believe that the data service providers, analysts, and those of you who may work in the field providing these products, how you can best learn from us and then provide us with the quality data that allows us to respond or to transport, to navigate a very, very severe and challenging Arctic environment. Don't let us dissuade you from learning, because if you're in the, say for example, you're in the sales or you work in a commercial service provider, it's not always a sales opportunity, it's a learning opportunity. And I want to encourage you to join us out in the field as we're navigating so that you can learn from us. I'm not a firefighter anymore. I'm more a behind the desk person and more of a policy person. But when developing emergency response policy for the Arctic, or when deploying resources for oil spill response, search and rescue, we don't have time to question the accuracy of the information. We work in minutes and hours and not in months, weeks, months, or years. Those who sail in the Arctic or who make their living in the Arctic deserve the attention to detail that I know that you want to provide, that I know that you will provide, to make sure that the fragile Arctic environment remains pristine going forward. I'm excited to learn a little bit more about the science, the accuracy, the attention to detail in the data, and I appreciate your time. Thank you very much.
Thank you, Ben, for this hey, stay up here. I think you actually had such a good, concise presentation. We have time for a question. We have time for a question if anybody has a question.
Everybody gets ice cream if there's no question. Oh!
Katarina.
Yeah, I'm just wondering if you could comment something that you're expecting timely attention to detail, correct? On a minute and, you said, yeah, minute scale, right? Attention to detail on a minute scale in sea ice.
So, no, but yes. We have to respond in seconds and minutes, and we have an inherent trust in the information that we're provided. I don't have an expectation that products provided by the Norwegian Met or the UK or the US Ice Service are minute to minute. That is an unreasonable expectation. But as those services are provided, we still have to make those decisions. When you're the captain of the ship, you have to make those decisions in seconds and minutes. So that was kind of the correlation there.
Okay, yeah, thank you.
Yeah.
That makes more clear.
How much do you depend on, I know this is more land-based, but how much do you depend on community qualitative data on the shore that dictates maybe ice conditions like farther out at sea? And if you incorporate that information into the predictions or into what's going on in the entire situation holistically?
Good question. I don't have an answer for you. I don't know.
I love that. More ice cream.
Being honest.
Thank you very much.
Thank you.
That was a very good questions, and these are very good questions, and especially on the practical use of information. And I hope we keep this in our minds for later as well. So, I would like to continue our presentations from the practical perspective, and I would like to introduce Jeremy Altendorf. He's the Associate Director for the Arctic Programs in the Office of Research at the University of Alaska in Anchorage. He also has a long tenure in the U.S. Coast Guard, and his expertise is in marine environment protection with oil and chemical spill and response.
All right, good afternoon. Wow, that bright, that's lights is something else. Okay. Why am I here? So I think this is a good, whoever put together the order by which we're talking today, I think really was brilliant, because I think I can address that question a little bit. So ADAC Arctic, it is a DHS-funded center of excellence, Department of Homeland Security, and we serve typically FEMA, Customs and Border Protection, and U.S. Coast Guard. Those are our customers. So, and my presentation is going to be talking about the work we're doing, kind of answering that question of data and how we serve operators. The whole point of ADAC Arctic is to make the operators' lives better in Alaska and the Arctic. And I think one of the things that the first presenter, did you see the sea routes? So at the bottom of the screen, as it goes into Europe, like there's all, the sea routes kind of all diverge. But at the top of the screen, they all came up down through where? Bering Strait, outside of Alaska, right? And so those that live in Western Alaska are uniquely going to be impacted by any vessel issues in that area. The traffic is only going to increase. I've been to Nome and a number of the communities, indigenous, et cetera, in Alaska, and this is a giant concern of them. On top of all that, Western Alaska has received, in the last few years, I moved to Alaska in 2017, and since then, in the last 5 years, there's been 2 typhoon remnants that have hit Western Alaska and caused a great deal of pain and suffering in Alaska. And we're, as a state and as a federal agency, struggling to meet the needs, the data needs especially for our first responders. And when I say first responders, I'm talking about communities who have first responders. Some do, some don't. But I'm also talking about how our federal responders, who end up probably a little farther down the pointy end of the spear than they normally would operate anywhere else, because it's Alaska, because it's the Arctic. So data, drones, and decision making. So ADAC Arctic, again, serves DHS. And what we're trying to do is this is a picture of Kipnuk, I believe, following Typhoon Halong, which occurred in October of this last year, and just devastating. And there's I introduced the emergency manager for the state of Alaska in my talk on Monday, and we talked about Typhoon Halong and the massive evacuation of folks from Kipnuk and Quilingok in the area, and what it did and how little press it got outside of Alaska, which is a real shame. But that's the realities we're facing in Alaska, and especially Western Alaska, as traffic increases, as commercial vessel traffic increases through that strait, as these new routes open up. The pressure on communities along those coastlines is increasing because of that, and also because of the increased environmental uncertainties, climate change, weather impacts, et cetera. So again, ADAC Arctic is about building capacity through operationalizing research. So data tools, community integration, and workforce development. That's the name of the game for our center, and that's what we try to do through the Office of Research and through the funding. We just released our Year 3 request for proposals, which is all about Arctic domain awareness. So we're trying to answer those data questions, right? And how do we work that? So I'm going to go over a couple of projects just to kind of give you a flavor of what we've been doing or are going to do, and then end with some messaging and certainly answer any questions if we have time. So Safe Arctic is a project that's been going on. This is year 3. And the end of year 3 is really going to do a couple things. Number one is they're going to use, they've spent the first 2 years working with the community of Nome and Teller, which is in Western Alaska, and bringing in indigenous elders and sitting down and talking with them and essentially creating bespoke map sets that are now integrated into Arctic IRMA, which is the GIS system of record for emergency managers, both in NOAA, U.S. Coast Guard, et cetera. So those maps essentially provide data that you really can't get anywhere else because it's formed from talking to the local community, to indigenous populations, to Alaska Natives. So they've taken those maps and essentially created a scenario, and are going to have, and they're going to. This whole project is going to, I think, going to end with a exercise in both Nome and Teller. And Teller is a community 3 hours north of Nome. It's got about 100 people in it, I think. And what's unique about Teller is there's a place, a port of refuge, essentially, Port Clarence, where a lot of ships end up in the Bering Strait if there's weather. And when I say weather, I mean the kind of weather like you really, as a captain, really try to avoid. So if you're moving or trying to stay safe, that's one of the better places to be. But again, it puts a lot of pressure on the communities there. So the idea here is just to create a preparedness system to actively engage communities. And how does Nome and Teller interact with each other? Nome being the de facto regional hub, whether they like it or not, where the hospital is and where you can get a flight out to Anchorage, essentially, right? So there's going to be folks in Anchorage, Nome, and Teller all kind of communicating and playing through this scenario-based system using the maps developed under the project. So that's what that's doing. Here's a new project. We're just getting started, but it's a test bed. One of the things I think, and I don't think, I've heard from rural Alaska and Arctic populations is the researchers coming into town and not really having any idea how anything works in places like Nome and Teller. Are super challenging. We spend a lot of money funding research, and we want our researchers to not only be welcomed, but be integrated into communities in a way that's meaningful and helpful. And often that connection is lost when we're not doing what we should do to set them up for success. So part of that is using the tools of record, again, GIS software, Arctic IRMA, things like that, where we can build a system that allows researchers to tell us what their requirements are, and then we help them navigate, like, okay, you need access to a fresh water body that opens up into saltwater. You need to house and feed 5 researchers for 2 weeks in May. You need to have a rental car with a truck, or you need to offload some big piece of equipment. Any one of those things can kill your project if you don't have the right forklift to offload it from a plane. If you don't have lodging, if you don't have rental cars, like all of these things happen in communities where research takes place. So those are the kinds of things we're doing. Again, we're trying to build a one-stop shop for that. It's in the nascent stages. We're just getting started on this, and we hope to have something soon to show off. Drone community practice. This is a big project that's focused out of Unalakleet, which is kind of a sub-regional hub in Western Alaska, where it's a decent-sized community. And Dr. Guerin with UAF has partnered with us under DHS, ADAC Arctic, to create this drone community practice. And basically, she goes to Unalakleet and trains folks on how to fly drones, gets Part 107 certification. And down here, you can't see it, emphasizing training and trust, not just technology. And I can't emphasize that enough, that dropping in resources and then walking away. The federal government's replete with examples of just dropping money in and not offering anything beyond that. And what makes this project different is how much hands-on and how much trust building in the community there is. And having somebody there to do pre and post drone imaging is pretty spectacular. And we're trying to replicate that program across the state in more areas, but this program has seen a lot of success. I'm very proud of it. Okay, so I'm coming up on time. Couple things. Number one, data is only useful if someone can interpret and act on it. I spend a lot of time responding to oil spills and building emergency response centers, fusion centers, like that come from the ground up. Y'all were right. There's all kinds of data inbound, but the ability to absorb it, synthesize it, analyze it, and then visualize it for everyone is so super challenging. And every data stream requires a body. This is Jeremy speaking, by the way. It's not the position of most federal government. We like to collateralize everything, like, okay, well, you've got these 5 hats. When it comes to data management and synthesis, that does not work. Every data feed needs a person to manage that, to answer those questions, like where's this coming from? Has it been QA, QC'd? How do we integrate it into our plans, to our methodologies, to our intel? So we are building, as part of this program, as part of ADAC Arctic, a workforce of the future. Like, how do we get the future leaders of the Arctic in here? So UAA has an Arctic Master Security Program. UAF has a PhD program they're very proud of. There's a lot of work in this space to develop future leaders, so we can get maybe a little bit past the same 10-person problem we have. So I spoke a lot about developing the next generation of operators, analysts, and researchers. That's key. That's what ADAC Arctic is all about, and we hope to continue that in the future. I know I'm out of time, so we're trying to use tools that exist, so we're not building something that, that's system agnostic, right? We want that kind of usefulness across the board. Operators don't have time to download things, like figure out how to do this and make sure we have the right subscription models and, all of that stuff. We need something easy that we can deploy quickly that has the kind of data that they're looking for. Yeah, so we invite collaboration. I'll be around the rest of the talk, this session. Happy to engage with questions about the RFP. It's a 10-year funded center through DHS, so we hope to continue that work into year 4 this time next year. So happy to answer any questions, and I appreciate your time today. Thank you.
Thank you very much for a fantastic presentation as well. I think we have time for one question.
What are some of the trust building strategies that you have or that researchers have had in the communities that they're working?
So I think the main one is being there in the community and really taking the time to ask questions and to have meaningful engagement. A lot of folks, and I've given my federal brethren a lot of crap for this, where there'll be like a conference in Anchorage for a couple days, and they'll come in a couple days earlier because they're already traveling, and then they'll head up to Nome or Ukjavik or Kotzebue, and then on their choice, pick a day where they're available, and then expect everybody to show up. That doesn't work, and in fact, it's just not great, right? So when we do these projects, we insert ourselves, we being ADAC Arctic UAA, and the University of Alaska system has a lot of history with indigenous communities and working with Alaska Natives, and so we use that power, we leverage that to help researchers. Like, hey, take a week, even though it might be a 1 or 2 day engagement, be there for a while. Take the time to get to know everybody, and we've hired, as part of Safe Arctic, a local planner through their LLC to really establish credibility in the community. So that helps a lot as well. So thanks. Great question. Thank you.
Fantastic. Thank you. So I think we're going to have our last speaker of the session, but I do want to say that I really do appreciate the speakers. We started with looking at the big picture, looking at very relevant, easily to visualize metrics. We come from the practitioner perspective that really focuses actually on a lot of energy and time that we focus on learning the information, on the uptake, and also thank you, Odd Svedhag from the Coastal Administration, to talk about how we share information with using best practices and common standards. But again, we are going to go further with a lot of sources of information. And trust so we're going to conclude this panel or this session of presenters with Ed Blockley. I would like to introduce Ed Blockley. He leads the Polar Climate Group at the UK Met Office Hadley Centre. He also specializes in ocean and sea ice modeling and forecasting evaluation, and he is focusing on transitioning the research into operations. Ed?
Chose the wrong route up. Okay, thank you. Thank you for having me here, having me speak. Yeah, I'm Ed Blockley. I lead the Polar Climate Group. I'm going to talk to you a bit about Arctic shipping and how is risk changing. And very briefly, just to motivate, I don't think anyone here doesn't know this already, so I'm not going to spend much time, but Arctic sea ice is declining and shipping is increasing, and you've already seen this picture on the right from Malta. I stole, that's two of his figures that I've merged together just to show. And the key point here is what I'm interested in, what we're interested in this piece of work is how is risk changing. And this is very much a collaborative piece of work that's been done mostly not by me. I've been involved in this activity, so this has been done mostly under the project called Arctic Passion and been led by Jackie Dawson's group in University of Ottawa. And I put Sierra's name there in bold there because she's really done quite a lot of work in bringing a lot of these slides and data together. So what's been done in this piece of work is the idea is to improve the Polaris, the risk assessment methods, by analysing historical ship traffic information and coincident sea ice conditions to try and work out what has been the risk exposure of observed ship track. So there's 5 pieces of this work here. So the idea is that we've prepared a ship position database, but it's been augmented with information about the ship to come up with a more useful database of Arctic shipping, which we then compare with sea ice charts to work out what retrospectively an assessment of what the risk was. I have some caveats in a minute, I will come back to it. But firstly, just to talk about this data set, so University of Ottawa, Jackie Dawson's group have developed this data set, and the ship positioning is from the AIS. This is very similar to what Malta was showing earlier, but they've augmented it with information about the ship because the risk assessment of go or no go in sea ice is very much dependent on the strength of the ship involved. So they spent a lot of time classifying over 45,000 ships in the Arctic with information. This is a particular picture for Le Commandant Charcot, which I think is one of Europe's most capable icebreakers, but it's actually a cruise ship owned by Ponant. And they've done this for all of these 45,000 ships to create their database. I'm not going to show you all 45,000, and this is just one example. And what they've done is they've then taken that information and taken the ice charts. So this is a Canadian ice chart here, I think. But what they've done initially is with the US NIC ice charts. But the Rio assessment, for those that don't know, it's there's an equation on the right there for those that like equations. But the idea is it takes the sea ice situation along the x-axis of this graph and the ice class of the vessel, and then you come up with a number to say, and if the number is greater than 0, then it's normal operation. If it's below 0, between 0 and minus 10, there's elevated risk, or there's high risk below minus 10. It's often said as go carefully, don't go. And so they've done this retrospectively with this is a NIC ice chart here. This is the same ice chart, but this is what the risk index would look like for 3 different classes of vessels, so PC3, PC7, and 1B. And as you can see, as the ship is relatively less ice strengthened, the risk goes up. There's a lot more orange for the PC7 than for the PC3. The PC stands for polar class. say. So before I show some results, I just want to talk a little about limitations. I want to make the point this is very much a research exercise, trying to understand shipping risk and how that might change over time. But there are a number of caveats. There may be position accuracies in the AIS. We saw a really interesting talk in our session about jamming of AIS signals. There's also precision of the ice charts themselves. I mean, we don't claim that they're 100% perfect. There may be inconsistencies in timing between when the ice chart was released and when the vessel was actually there. And the key point I want to acknowledge is that the decisions are taken by the ship's master on the ship using, as Ben has told us, a huge array of different data. And this is just a research exercise to see what, with a large enough data set, there are interesting things that we can say about it. So here are the results. This is for the 7-year period, 2015 to 2021. These are all of the ship positions, 262,000 ship positions from 2,152 different ships. And the colours here, you could see them, is dark blue is open water and light blue is ice-infested waters. So mostly, it looks like mostly ice-infested waters here, but majority of the shipping is focused in areas with no ice. There's actually 47,000 ship locations in the ice-infested waters. So then we applied the risk indices to this, and you can see the colouring. And reassuringly, quite a lot of it's green, which is nice. There are some areas of red, particularly northwest was Svalbard, but particularly there. As Malte pointed out, there's a lot of Russian or natural gas there. This is just north of Sebetoport on the Yamal Peninsula. But the bar charts on the right are showing the interesting results. So clearly, shipping is increasing. You can see the bars increasing from 2015 to 2021. But what's interesting to us is that the yellow and the red is not really increasing, which is great. So the numbers, you can see the 2020 reduction from COVID there, but largely it's fairly similar, and that means that as a percentage of the total shipping, actually the number of high and elevated risk instances is actually reducing. So from this, I draw a few conclusions and statements. So we've retrospectively produced this analysis of Arctic shipping risk using the IMO's Polaris Risk Index outcome, the RIO. This has included quite a gargantuan effort of classification of all the different ships, which has been really interesting. I've got a really interesting database now at the University of Ottawa. And for those that know Jackie, she's very keen to collaborate, I think, on these things. And but what they've done is we've matched up the vessel locations with the ice charts to get an understanding of how risk is changing. So firstly, you can see those, as I said, those green bars increasing. There is, as we know, there's been a clear increase in Arctic shipping. It's about 4.5 times as many ships in 2021 as we saw in 2005 at the beginning of that period. But crucially, we find no increase in risk-taking, which is fantastic, and that also means a reduction in the relative proportion of risky activity. So I think what this means is that maybe two things. Either the shipping, probably is true, the shipping community are generally quite conservative and quite safe. It looks like the increase is being done in a safe way, which is fantastic, but it may also mean, Benny, that they're getting the information that they need. But we haven't dug into those reasons. But so yes, thank you very much. Any questions?
Thank you again for a fantastic presentation. We can definitely take some questions. Katerina?
Okay, I can just speak like that, if everybody can hear me. I just wonder, according to your, well, I know that you have used the recommended procedure, but in the whole approach, it doesn't matter if the ship is carrying logs or 3,000 passengers.
No.
And do you think it's representative of the risk picture?
So that there are some slides I have further below that show the different classes of vessel as well. We haven't found any conclusions about class of vessel, whether that's any different, but I know that there are lots of new actors in the Arctic, like...
Just to comment, the Polaris recommended procedure only considers likelihood of
Yeah.
structural damage. That's it.
Yes.
So when you label this risk, it has to be clear, it's only likelihood of structural damage. And if you want to have a bigger risk picture, you need to use a different model.
Sure, yeah.
And those who are not happy with IMO Polaris should join the team, because now I think people are working on updating it and
Yeah.
making it better.
Yeah, I mean, as Multi said earlier, that, you know, that's clearly there. This is it's a very basic first stab, I would say, at risk. I mean, when it came in 2016, it was, you know, fantastic compared to what we had before.
But just be
But
careful,
I
like,
think
in
there's
general,
more.
for everyone, the narration of risk, because what you actually is doing, it's a likelihood of structural damage. That's how the recommendation itself is built upon. They say risk on the title, but if you go into details and start to read, there are small text which says what it is.
Sure.
Perfect, thank you. That was really nice. Do we have any other questions? You gotta take one more? Yep.
Just building on that, I wondered what is the prospects for including not risk to people on board, I think implied in your question, but also risk to the environment in some particular areas.
Visibility conditions are there.
I don't mean from a spill or a, yeah.
Yes. Yeah, so this is only, as you've heard, this is only sea ice, and it's only risk of damage from sea ice. It doesn't take into account what's on the ship, whether it be lots of people or crude oil compared to logs, as you say. I don't know whether or not that will be included, but it's certainly something that should be, you know, considered by search and rescue and by the ship's captain. I don't know. I mean, I'm not a ship's captain, but I would be, yeah, concerned about what's in the ship. Certainly.
What's outside?
Yes.
Yeah, that's all right.
Yes. Well, of course.
Thank you very much. And I would like to give a hand to all the presenters at the session. We'll continue this discussion with a panel session, and I would like to say that this has been very nice, and also thank you for plugging the the ice services, the operations. But I will say we definitely need a lot more information. So, okay, give us one moment.
So we have a full stage then for our panel. And since Penny, you've been plugged so many times in the different presentations, it's only natural then that you also have a spot on the panel today. So I wanted, to follow up and say thanks to everyone for the really interesting and also innovative perspectives that you had offered and shared. And there was a lot of good nuggets that everyone kind of placed for me to follow up on for questions. So I think we can, and you can obviously disagree if that wasn't a good kind of assessment, but I would say that it seems that we all agree that there is a plethora of information. There is an potentially opportunity to optimize how we use that information. And then there's also a lot of real-time factors and considerations that we have to take into account. There's the operational, tactical level about what's happening, especially from a maritime perspective. But there's also this time element, Ben, that you had referred to, especially when there is these incidents or potential incidents that we have to also operate in timescales that really don't offer the opportunity to really go into depth or to have that, discussion back home with the command center and so forth. So this often, from a practical perspective in the field, is that we see that even if there are these really great advanced new technologies and information out there, people may end up relying on things that are just comfortable. The charts that you have used for hand-drawn, for even maybe those maps you guys probably used for a bit before you went into the new maps and so forth. So there's a bit of a balance, right? Especially when we're trying to get the data uptake or try to get the users to understand the potential products, that it takes time. And there's that trust element, Jeremy, that you had mentioned, that it takes time to build that. So I think to kind of put on different hats, it would be interesting to see if we're thinking about, especially from an operator, because, we're not operators per se, but we can at least see the perspective that they might have. But in a hazard, what would you think then, Penny? Would someone turn to a reliably quality-controlled product that would arguably be good data? Or would they go to something that's easy, familiar, and potentially inaccurate?
From our experience, I think that people would take, they would certainly use a reference from maybe the national services, but they would take what they're familiar with and what they know, and actually what's easy. I think the 5 major qualities of the data that we know from those on the field is that it has to be relevant, it has to be accessible, it has to be reliable, so they can depend on that it's going to be available, and they have to be able to understand it. So I think it's as simple as that. So I think there's a lot of components to get there.
Sure. And then Malta, then I will pass it on to you.
Well, no, I got challenged, so it's difficult with the operator hat sitting between 2 operators.
You're okay.
Yeah. I fully agree what you said, Penny. I think when you think about short time scales, they have to use what they are used to. You don't use a new product just because a scientist or so tells you it's more fancy or more accurate. So it's definitely this perspective. But I think there are also different timescales when you think about emergencies. Like for example, with this North Guider incident we had in Svalbard, where the ship was grounded in Hinlopen Strait, there was like this short-term action to get the oil out of the ship, but then they had to have this decision made if they can remove the ship in the winter, like in the polar night, or if they should rather leave it there, so it's a lower risk actually to remove it in the summer. And then they actually asked different research centers and also forecasting centers for input and assess this over a longer time scale. So then they actually had the time to use much more advanced products and have discussions with experts. So I think that these 2 perspectives. So if in the end, I think they need also the contact points at the centers, at the research centers, how they can support in some of the situations at least.
Absolutely. And then Jeremy, I think also to bring it into this different Arctic's perspective, right? We also have a pretty unique position, as we've touched on in the earlier session, in Norway, where smaller community, kind of longer circles of trust that have been established. Generalizations, of course, but it's a very different context, right, than Alaska. So how do you interpret all of this discussion and what you've been also presenting in your work, and that element of trust that you alluded to at the end? And there's a lot of people that come up to Alaska that aren't based in Alaska, working on Alaska, right? And so that context about researchers not really knowing what they're getting into. Mm-hmm. Does this transfer then to the context in Alaska, what we just heard?
Yeah, yes, what you said about data applies whether you're in just running, captaining a ship or managing a port or living in a community. Like everybody has their own data source, but it is so built upon not only what you're used to, but also your ability to integrate, synthesize, and visualize data. And so if you're an emergency services person, you're a public safety person, you're running a fire department, and you're in Nome, there's only so much data you can bring in the systems that exist in a volunteer fire department setting, right? And you might be able to overlay that with a city management GIS system, but it is very purpose-built for things not related to what we're talking about when it comes to like emergency response. So that data will come from some other place, right? And so communities, I think, build trust. We build trust by going to communities, establishing a relationship, and talking about, we don't have to tell them they're on their own for 72 to 96 hours. They get it, right? How we integrate our operations and how we manage that data transfer so we can pull in, synthesize it, and then start bringing in resources, that's the key, and that's what we want to continue practicing. But we also want to trust like the maritime community when it comes to like what I saw in that last presentation was, yes, it was very limited about, we've narrowly defined risk, right, based on what, but I like what I'm seeing, which is, and it tracks with IMO and the global maritime community, is they're not risk takers. Nobody wants their cargo, regardless of what it is, out there in the environment, right? So I like that we have data even limited in that aspect that it tells us like a story like, okay, so they're not taking huge swings of risk in certain ways. What other things are we looking for? What trends can we find in the data? And that is done with DHS back at Anchorage, and again, synthesizing that data and coordinating it with local communities is a challenge that we continually have to do, and that requires funding and a constant like vigilance of exercises, working with the Arctic Council and getting that data in and having these conversations. So it's a constant like circle of trust, and building that relationship is key, because if you don't have the relationship, then the data is almost lost in that, and it won't happen. So I hope I'm landing on a point, which is it does start with trust, and the data that comes in is very much based on what you're doing, and the challenges in emergency response, like integrating that data in a way that's helpful and not overwhelming.
Well, I think that then was a perfect segue then to you, Ben.
Oh, I'm ready. I have thoughts. I'm always waiting for you to shut up, but that's okay. I have thoughts. Can I just dive in?
Absolutely.
So trust, sorry, this is exciting. And it goes back to the question that you raised during my session as well. SAR and RIOs, and we've heard a lot about data and trust. And a lot of this has been satellite imagery and SAR and all kinds of fancy stuff. And I know that's not an analytical term or a scientific term, but a lot of stuff coming at us. It's important. So from an Arctic Council standpoint, it's really important for me to underscore that trust goes two ways. And as analysts and as digesters of information, we need to trust our Indigenous partners, and that Indigenous knowledge is equally as important. And in some cases, depending on the community, but we're doing soundings every 10 minutes because the charts where we were sailing were, that bathymetry, whatever the right word is, those charts were made in the 1800s. We as emergency managers and as data analysts and as providers need to recognize the importance of and trust that IK, that Indigenous knowledge. So that was one part. I don't think I have a second part, but I know you have a question.
Well, yeah, I think this is a question then really about who is putting themselves at risk, right? Like what is really the end user, apart from day-to-day operations, which need to still have this information. But I think it's kind of a bit the point that you raised, Ed, and I'll bring maybe the microphone down to you then. We saw with Malta's presentation that there has been kind of more risky situations, but also there is ultimately a conservative group of operators, especially out in the deeper Arctic. So where really is the hazard? I think that's also the question, right? Like, where is actually the risk? Who are we targeting? Because typically most of the indigenous hunters and so really know the area. They're not typically the ones getting in these really risky situations, also due to the breadth and kind of the what's on board and how many people are on board. But at the same time, there's the near misses, right? We're not getting that information. So it could be that we're not preparing for the right risks.
Oh, yeah. So you have some thoughts on that. So one of the things in the Bering Strait, like the farther north you get from the Aleutian Islands, you can tack on a day extra for a response to be executed, right? So the risk we're taking on, I mean, I'm all for commercial maritime traffic. It's the way of the world, and it is what it is. But our lack of infrastructure is the risk. Just more things to fail is the risk, and that risk is mostly burdened on the people that live on the coastline, as you certainly through the Bering Strait, and so there is a push to provide better infrastructure to support. I mean, if we're talking about the analogy is highways and gas stations, like that major highway has 0 gas stations along the way, zero, right? And so is there something we can do to reduce risk if we're going to see more maritime traffic? We know the IMO is going to do things, albeit slow. We know that captains, generally speaking, are not big risk takers, but that doesn't change the inherent risk that's existing. Also, typhoon remnants and atmospheric rivers are a new thing. It's a new thing, and it's going to continue to happen, and it's going to be more frequent. And I don't know what the populations, if the population centers in those areas are already suffering through calamities and emergency responses and evacuations and constant vigilance of weather conditions, how are they going to support or manage an extra outside response? And so there's all of those inherent risks that happen that you have to evaluate, right?
And how does that sit with you, Ed?
So yes, I mean, as was pointed out in my talk by Katarina, there are lots of risks that are not just the crushing of the ship from sea ice, and and particularly as the sea ice decreases, you get new risks, as we just heard about typhoons. But fog, vessel icing, things like that will become more relevant. But as to who takes on the risk, I mean, of course, if a ship wants to operate in the Arctic, they themselves have taken on some risk, and they've chosen to do that. So there's risk to the ship, there's risk to the ship owner, probably not the same person, and there's all the crew on board. But there are also risks to things that haven't chosen the situation. So there's the local populations and the ecosystems. There's risk to people like Ben out on his Coast Guard ship. If there's search and rescue, then we should not forget that those people are putting themselves at risk to save them. And so dangerous and reckless behaviour really. We don't want to see that, and so we were very pleased when we looked at this analysis to show that there doesn't seem to be, although crude as it is, it doesn't suggest that there's a big increase in risk, which is fantastic.
Sure. Well, I think multi-year and I'll just
I have one tiny opinion.
Yeah.
So I have 2 thoughts real quick. One, I don't think anybody wakes up in the morning and says, how can I make the Arctic worse? I fundamentally, if you're a reporter, you can write that down. I don't think that anybody wakes up in the morning and says, how can I make this worse? That said, and perhaps one of the risks that hasn't necessarily been considered is the geopolitical risk, and there is shady, dodgy, bad tonnage sailing through the Northern Sea route, and that is a risk.
Good comment, thanks. So just adding to this whole risk discussion, I think it's important that how we communicate the messages, so that just what was mentioned earlier, that there might be not an increase in risk taking from that perspective of this Rio risk assessment. But if you are going in the polar night along the Northern Sea route, or in the shoulder seasons, I mean, of course, you are increasing the risk that something happens, and you are far from any infrastructure. So I think this is also not taken into account how far actually people go away from search and rescue response services, also oil spill response services, and so on. So there's almost no infrastructure along the Northern Sea Route or in other areas. So I think, I guess if we communicate this to the outside world, we have to be very clear what we mean by the risk we are talking about.
Well, that's a really good way to transition to you, Penny. The we part, right? We communicating, and those of us that ultimately have authority and responsibility to put out this information. How has this been changing for you, especially in recent years? Do you find that this is getting more challenging, more complicated? Yeah.
Yes, I think, no, it's certainly more challenging because dealing with the sea ice in the Arctic, we certainly have a lot different ice regimes, and it's changing very quickly. So this really introduces a bigger challenge for operations. I do think that to work on a tactical or in a short-term level, we need to actually really exploit the use of a system of sensors that we actually have available, but it still continues to be resource intensive, and we're not using them as much as we should. So this is why we do need to expand our information portfolio, but also we really need to use the correct sensors for the correct parameters, and not every sensor is used for every single thing that users need. I think from our perspective, we understand the parameters and the information users need, and it's our job not to provide this exactly, but to understand which satellite sensors and which types of information are capable of providing this information, because what they're talking about is the information they need to make a decision. So that's our job, to make it relevant and easy to ingest onto their systems, make sure it's standard, make sure we're sharing best practices, and that is a huge challenge resource-wise, satellite-wise, technically-wise, and budget-wise. But it's necessary.
Yeah. Well, I think also you bring up a really interesting point, and both the users and the data providers, in a way, has been a traditional set of actors for a large period of time. But we're also seeing the advent of third-party actors, private companies coming in, providing information, especially to the maritime industry. Also, our users are changing. There's a lot more of individuals going out into the Arctic than we have seen before. So how does that also change the landscape of responsibility and trust in terms of we can't just necessarily go to a community, and that's kind of hitting our most important user base, but there's also a lot of other actors that we're missing. So especially as data providers, and maybe we can start with you, Ed, how is this new landscape changing how you guys think about both providing information but also reaching your end user?
In the UK, one of the new actors that we have a lot of interest from is our own military. So they're through NATO, they're very much aware that they need to operate more in the Arctic, and in most cases it's quite new to them. So we have been doing some outreach to them to provide some training on what sea ice is even, and how it moves and how it grows and things like that. And I think that face-to-face discussion is really important, and particularly Malta was talking about the Coast Guard engagement, which I think is also fantastic, and the trust is really important. And we talked a bit about trust earlier, but I was thinking at the time, I recall that an anecdote from the UK. There was quite a lot of discussion about when we had the Brexit vote, but there was an interesting piece of science that someone did, which was to show that in general, this was true in the UK anyways, people would rather take financial advice from their brother than from or they're more likely to act upon financial advice from their brother than from some guy in a suit that they just met that morning. And the key thing is about the trust. So expertise is not enough. You need to have that trusted relationship, which is really important. And you can only build that through co-working and interaction.
So I think we can pass around for everyone to kind of give your final, what's your main message that you want everyone to walk away from this session, and what do you hope to see? If you were to leave people with a one or two liner, a little zinger.
Let me start. Yeah. No, but I see, and we work with research, we work with end users, we work with the information providers from government to third party, and I think we all need those. And I think that what I think from the presentations here really demonstrated that the visualization, how we present the data, certainly the source, but how we present it to make sure that this is intuitive for people. This really makes a difference. I think we use the example from Windy or so, and those this is something that people use over national weather services a lot because it is very easy to use. Also, the amount of energy and time it takes to build this feedback loop, that we have a lot of information that is available, we have a lot of information that is going to be available. It's necessary to use it, but we also need to integrate this QC oversight and really make sure that we spend the time doing this. Not everybody can go on ships all the time. It's good if we could, but if not, then we need to figure out how to systematically disseminate this information to everybody so that it's easier to understand for the public and that we can really increase our information output.
And you, Ben?
All right, so I've been harping on go out to the ships, go out to the ships, go out to the ships. Invite the ship riders, invite the crews also into your facilities. So that's a two-way street. It would be disingenuous for me to say, you need to be on a ship, you need to be on a ship. Invite the user into the laboratory, to academia. Is it Alessio? Am I getting that name right? Be an Alessio. So that's what I'll end with. Don't be afraid to get your hands dirty or to invite dirty hands into your facility. That didn't come out right, did it? Wash your hands. I gotta stop now.
I just want to follow up on this. Not exactly what you mean. But so being Alessio, I mean, I think it's more general that, so from my experience, I think we should work more interdisciplinary so that if you want to speed up the processes from, for example, natural science, development of forecasting systems or other model systems, going all the way to the end users, I think we need to work with the social sciences, and we need to work together with the end users going on the ship or doing workshops, doing co-production cycles with them together. I think it's also very rewarding and refreshing, I think, this kind of work, because you really feel an impact what you are doing very much more quicker than when you are just sitting at your desk and working on your model system and reporting on verification assessments and so on. So I think that's maybe my main message. If we want to get our products, our data faster as information to the people on the bridge, I think then we need to work better together, transdisciplinary.
I think I'll underline that point and just say research that is focused on operationalizing outcomes has to really engage with the end user, or it's not going to be successful. And that is a challenge between academia and government. Government pays academia to do a thing, and they create some bespoke product that costs so much money to deploy, it ends up in a warehouse out back and never used. My career is replete with that example of research, and I don't want to see that in the Arctic. I want to see a real work in getting research operationalized in a way that integrates well with things like a mobile phone or that Dell computer that was issued to the city of Nome, and like those are the kinds of ways we will get data into end users. And doing it any other way is kind of not realistic, right? And so again, managing, analyzing, synthesizing, and visualizing data in a meaningful way is everything. And I think that's what prevents accidents and reduces risk, and really can be beneficial across the board. And so I think I will leave it at that.
You have the final word then, Ed.
Well, yes, everything's been said to some extent. I mean, I already said my piece about trust in the last one, and that's really important. And other point I was going to make was about the simplicity and the familiarity, which my thunder's just been stolen for.
Sorry.
But Dina, you started off the first question asking, what if the user just uses the product that they're familiar with instead of a new product? And my thoughts then were, they absolutely should. They should be using the product they're familiar with. That's the most important thing. What the question we have to ask is, how do we make them familiar with the new products as they change? And perhaps a more personal story, but my father's in his 80s, and his mobile phone he got in the 1990s, it died, so he's got a new one. It's almost identical in functionality, but it's apparently terribly scary, and so we have to we try and explain to him, and he seems to be able to work it fine. And the next time I go there, it's not even charged. And I say, "What's wrong with that?" "Oh, well, it just doesn't work." And so it's about repeated. And I'm not comparing you operators to an 80-year-old man at all, but I'm just saying that he's very important to keep that relationship and evolving things, and not to completely blitz someone with thousands of different products at once. I mean, Ben showed the picture of the guy dying from data, and so we need to make sure that we're simple in our message and in how things are used.
Well, thank you all very much, and thank you everyone for your attention, and thank you for a really great session.